In this video, I'll explain how to create an interactive particle and line effect that responds to a person's movement in a video. Also, the version I made into a TOX and turned into a tool is available on my Patreon, so please feel free to use it if you are interested. This project is made up of the following sections: radial flow setup, motion tracking setup, rendering and post-FX. How to customize the settings. On this channel, I also post short tutorial videos mainly focused on TouchDesigner. Additionally, the project files are available for download on my Patreon. If you find my tutorials helpful, I would truly appreciate your support there. We're going to add a movie file in top and load a video of your choice. We're going to add a fit top and set fit to fill. Go to the common page and set the resolution to a value of your choice. In this example, we're going to use 1280 by 720. We're going to add a null top and rename it source. We're going to add a top to POP. We're going to add a null POP. For rendering, we're going to add a geometry comp, a camera comp, a light comp, and a constant MAT. Drag and drop the constant MAT onto the geometry comp to assign the material. We're going to add a render top. Go to the common page of the render top and reference the resolution of the fit top. Next, we're going to match the area displayed by the render top to the source video. Select the camera comp and go to the view page. Reference the resolution of the fit top and enter the expressions shown on the screen. We're going to add a transform POP. Apply the expression from ortho width on the camera comp to uniform scale on the transform POP. We're going to add a particle pop and enter a value of your choice in maximum particles. Set birth rate to reference the maximum particles value. Set life expect, which controls the average particle lifespan, to 1, and set life variance, which adds variation based on the life expect value, to 0.5. We're going to add a keyboard in chop and reference it in initialize and start on the particle POP. This allows you to reset the feedback loop by pressing the 1 key on your keyboard. Go to the attributes page and enter color in input attributes. This assigns the colors from the source video to the particles. We're going to add a Force Radial POP. Set direction to, so that the force uses the z-axis as its base axis. Turn on Enable Spiral to add a spiral force around this axis. Drag and drop the Force Radial POP onto the particle pop to create a feedback loop. You can control the movement by adjusting values such as radius and position. You can see that the force created by the Force Radial POP is moving the particles. We're going to add a delete POP. Go to the attribute page and set the first attribute to part vel, 0, and the second attribute to part vel, 1. Particles are deleted when either their x or y velocity component is 0. Next, we're going to use the movement in the video to control the Force Radial POP. We're going to add an NVIDIA background top. We're going to add a constant top. Go to the output page and set combine with input to set resolution only. We're going to add a matte top. Connect the NVIDIA background top and the constant top as shown in the video. We're going to add a blur top. We're going to add a threshold top and set threshold to a value of your choice. We're going to add a blob track top. In this example, adjust minimum blob size and maximum blob size so that only one area is detected. Also turn on the delete option shown in the video. Select the pink arrow at the bottom right of the blob track top and open blobtrack_blobs. We're going to add a transpose DAT. We're going to add a DAT to chop and get the width and height channels. We're going to add a math chop and set combine channels to minimum. Copy the uniform scale value from the transform pop and paste it into multiply. Rename the channel radius. Next, we're going to prevent the value from disappearing when tracking is temporarily lost. Connect blobtrack_blobs to an info chop and set scope to number_rows. We're going to add an expression chop and enter the following expression. We're going to add a hold chop. Connect the math chop to its first input and the expression chop to its second input. Set sample to while on. We're going to add a null chop and rename it radius. Reference this value in radius on the Force Radial POP. The size of the particle vortex will now change based on the size of the area detected by the blob track top. You can see that changing the threshold value changes the behavior of the particles. We're going to add another DAT to chop after the transpose DAT and get the U and V channels. We're going to add a math chop and enter -0.5 in pre-add. We're going to add another math chop. Copy the uniform scale value from the transform pop and paste it into multiply. Go to the common page and enter U in scope. We're going to copy and paste the hold chop and replace input 0 with math 3. We're going to add a null chop. We're going to add a chop to pop, rename it attractor, and enter p.xy in attribute scope. Drag and drop attractor onto specification pop on the Force Radial POP. The position of the particle vortex now changes based on the area detected by the blob track top. Set radial strength to 0.5. We're going to add a select top and drag and drop source onto it. We're going to add a composite top. Connect the render top and the select top, and set operation to over. Make sure the inputs are connected in the same order as shown on the screen. We're going to add a circle pop, set connectivity to surface, and enter a value of your choice in uniform scale. We're going to add a copy POP. Go to the template attributes page and add color to copy the color information. We're going to add a proximity pop and enter a value of your choice in maximum distance. We're going to add an attribute POP. Add line width and enter a value of your choice to determine the line width. We're going to add a null pop and connect it to the geometry comp. We're going to add a line MAT. Drag and drop it onto the geometry comp to assign the material. Change the line near color value. We're going to add a bloom top. Adjust the values in the blur top and threshold top to control which areas are tracked. Adjust values such as radius, radial strength, and spiral strength on the Force Radial POP. By changing velocity damping on the particle pop, you can reduce the particle's velocity over time. In this case, the detection is already working correctly. However, if the detection does not work well, adjusting this value may improve the results. The NVIDIA background top is designed primarily to detect people, so its performance with other types of subjects is not guaranteed. However, it may still produce usable results with some videos that do not contain people. We're going to adjust the values. Increasing the line width value makes the lines thicker.